Today's video is about application of differential equations. Let's talk about the facts. When you have e to the x plus 6 power, you can write down a times e to the x. When you make a equals e to the 6 power. For the second fact, natural log of x plus c equals natural log a times x, when a equals e to the 6th power. The symbol used to denote the proportionality is this symbol. For example, if we say a is proportional to b, then it's represented as this. We can write down a equals k times b. Both sides divided by b, you will get the k equals a over b. If we say a is inversely proportional to b, then it's denoted as this. We can write down a equals k times 1 over b. Then multiply by b both sides, we get a times b equals k. Go to guided practice 1. The rate at which mass m of a black hole decreases over time is inversely proportional to the square of its mass m. Write this as a differential equations. According to the information, it says inversely proportional. The rate means differential equation, so we get the dm over dt. It's inversely proportional to the square of its mass. Therefore, it will be 1 over m squared. This word inversely. Therefore, for dm by dt equals, check this word decrease, that means will be negative. As we know, when derivative is a positive, that's the function is increasing. When derivative is a negative, the function is decreasing. The reason we put the negative sign here. Then times k times 1 over m squared. Then this k is greater than 0. This will be the differential equation according to the given information. To guided practice 2, a bloom of toxic blue-green algae grows in proportional to the square root of its existing size. When it's first noticed, the bloom covers 14 meters square. Its area doubles in next 3 days. Find the function of t for the area of a bloom after t days. According to the given information, we know the growth rate of algae will be dA by dt. It's proportional to square root of existing size, so square root of a. Therefore, you will have dA by dt equals k times square root of a. Since this is growing, therefore the k is greater than 0. We need to solve this differential equation. You will have dA over square root of a. We will put square root of a on the left side equals k times dt. Then integral both sides. For 1 over square root of a, I can write down a to the -1/2 power. Therefore, integral of a -1/2, you will get -1/2 plus 1 will be 1/2. -1/2 plus 1, here's a 1/2. Therefore, you will get the 2 square root of a. Therefore, you will get the 2 square root of a equals k times t plus constant number c. Divided by 2 both sides, you will get the square root of a equals k times t plus c over 2. Square both sides, you will get the a equals k times t over 2 plus c over 2 squared. According to the given information, we know that when t equals 0, a equals 14. When t equals 3, a equals 28. It says area doubles in next 3 days. Substitute back into this equation. You will get the 14 equals c over 2 squared. Sides, you do square root then times 2, you will get the 2 square root of 14 equals c. We substitute this into the function, you will get 28 equals t now equals 3, so 3k over 2 plus, we substitute the c equals 2 square root of 14 into function, you will get the square root of 14 squared. Then square root of both sides, you will get the square root of 28 equals 3k over 2 plus square root of 14. Then for square root of 28, we can write down 2 square root of 7. Then minus the square root of 14. You multiply by 2 divided by 3. Then that will be k. We substitute this c and k into this function. You will get a equals k divided by 2, you will get the 2 square root of 7 minus the square root of 14 over 3 t. Then plus 2 square root of 14 divided by 2 will be square root of 14. Then this square. This is the function we are looking for. Let's go to guided practice 3. Let A be the area of a circular ring formed by 2 concentric circles with different radii. At time t equals 0, the radius of the out circle R1 equals 8 centimeter, while the radius of the inner circle R2 equals 5 centimeters. And at that point of time, both radii start increasing with a constant rate 0.02 centimeter per second and 0.03 centimeter per second respectively. For A, find at what time t the area A will reach its maximum value before it reaches 0. B, find at what time t the area A will reach 0. According to the given information, they said that radii start increasing with a constant rate 0.02 and 0.03 centimeter per second, which means dr1 over dt equals 0.02. dr2 over dt equals 0.03. Solve these two differential equations. You will get the dr1 equals 0.02 dt. Here, dr2 equals 0.03 dt. Then we will take integral both sides. You will get r1 equals 0.02t plus c1. r2 equals 0.03t plus c2. So, according to the given information, when t equals 0, r1 equals 8. When t equals 0, r2 equals 5. 4. We substitute back to r1 and r2 separately. You will get the 8 equals 0.02 times 0 plus c1. So c1 equals 8. For r2, you will get the 5 equals 0.03 times 0 plus c2. So you get the c2 equals 5. Substitute back c to the r1 and r2 function. You will get the r1 equals 0.02t plus 8. And r2 equals 0.03t plus 5. The shaded area A equals pi r1 squared minus pi r2 squared. So you get the pi times 0.02t plus 8 squared minus pi times 0.03t plus 5 squared. Looking for the maximum value, we will set up derivative a prime equal to 0. Then using graphing calculator, you will get the t equals 20.0 seconds. For B, you will set up a equal to 0. Then using graphing calculator, you will get the t equals 300 seconds.